I'm Braden,
I'm Hayden.
and today we're going to be looking at a 1998 Acura TL engine coolant temperature sensor, intake air temperature sensor, and throttle position sensor.
Taking a look under the hood, you can see that we have the ECT right under the intake manifold on the front side of the engine. And then on the back side, we have the intake air temp sensor.
The engine coolant temperature sensor and the intake air temperature sensor are what called negative coefficient thermistors. So the way a negative coefficient thermistor works is that the resistance increases as the temperature decreases. So not like the conventional way of resistance increases as heat increases. So in this clip, I take a pot of boiling water and a ice cold bowl of water and dip the engine coolant temperature sensor in there, and you can see the resistance values change in the boiling water versus the cold water with an ice pack on the digital multimeter over on the right. Along with the changes in resistance in the boiling hot water or the ice cold water, you can also see that the resistance values change very quickly when dipped in either one, and they rise very quickly or they fall very quickly.
Alright, taking a look at the wiring diagram. On the left side, you have the PCM, which is sending power down through the blue and pink highlighted wires to the two different sensors, the ECT and the intake air temp sensor. And then those two wires are grounded on the right side through a common ground.
We have our ECT and IAT back probed for testing. Let's see how those sensors perform under a regular load.
Taking a look at our live data, you can see our PID values. Currently, we have displayed the intake air temp sensor and the ECT sensor. And then below that, on the multimeter, we're taking a look at the back probed ECT sensor. You can see the voltage drop as the temperature rises. This system also uses only a single range ETC setup, meaning that there will be no voltage spike or voltage change. It should just steadily decrease as the temperature increases. Taking a look at the vehicle when it's up to operating temperature, you can see that the voltages have settled down or have slowed down, and same with the temperature. But as the temperature reaches 205 on the ECT, it will kick on the cooling fans. With the cooling fans on, the voltage will increase again as the ECT cools off and increases in resistance. Taking another look at our PID value for the ECT, you can see that when it's unplugged, the PCM sees 5 volts and will just blank out the PID value for the ECT. In this photo here, you can see the DTC trouble codes that were set from us unplugging the ETC sensor, causing high voltage on the signal line back to the PCM.
The throttle position sensor, or TPS sensor, is mounted in line with the throttle plate on the side of the throttle body. It looks like our throttle position sensor has a broken ground wire on it. The wiring in it is the red and black signal wire, the yellow and blue 5-volt reference wire, and then the green ground wire. In this clip, my lab partner Hayden is taking pieces of an electrical wiring test kit and makeshift connecting the sensor and the connector pins to make the sensor work. Although the vehicle ran fine with the broken ground wire, we wanted to make sure the sensor was functioning properly. After rewiring the sensor, this is what the finished product looks like. On our first throttle position sweep test, we did not know that we had the 5-volt reference and the signal wire on the throttle position sensor swapped around, so the signal wire was constantly being fed 5 volts, throwing off some of our scan tool readings. As you can see here, when I press down the pedal, the voltage of the sensor is dropping instead of increasing, and the angle of the throttle plate is also decreasing when I push down. We now performed a second sweep test on the throttle position sensor after we had fixed our wiring inside the sensor so it could read correctly on the scan tool. I pressed gently down on the gas pedal to then see the voltage increase inside the sensor and the angle of the throttle plate as it's opening when I push down more on the gas pedal. And then I let off slowly to get a good reading of the line and see if there's any bugs or glitches inside that resistor strip.
Taking a look at the wiring diagram for the throttle position sensor, you can see that pin number 6 on the PCM is signal, pin number 21 is power or 5-volt reference, and pin number 1 on the sensor is ground. The problem with this is that the way it's configured, it causes the voltage to be high at idle, and then the voltage drops across the sensor when it starts to open up, meaning that I have conflicting information because if you look at the paper on the right, it shows that the voltage for the throttle position sensor should be increasing as the throttle is opening. While I did not get a chance to confirm which way is the correct way to have it wired, I believe the correct way is to have the voltage increase as the throttle is opened.